Well, so good morning. First off, everybody that's here, you guys grabbed a set of poker cards. Go ahead and open them up. Um, Open them up and pick out the jokers and set those aside so that you've just got the standard 52 cards. Um, okay, we need to go to Twitch here. Okay, so all right, so yeah, go ahead and get your cards unwrapped and um, pick out the jokers. Oh, right, wrong account. Okay, so I need to change OBS to be on Safari, not window capture. Here we go. Okay. All right, so I'm going to make a blank spreadsheet, but so here's sort of the idea of what we want to talk about today, and we'll continue on Friday. So let me start with kind of a simple example. You have to take 34 credits to graduate from Wabash. Okay, great. Most of you do it in 8 semesters. And let's assume that you don't come in with any AP credits or anything like that. So, how many courses do you have to take in a given semester? Huh? 4 for most of them. And then a couple of semesters you need 5. Now, maybe you reconfigure things and maybe you take 5 during 3 semesters, and then the second semester, your senior year, you like just do a lot of Cactus 101. I'm sorry. Yeah. You do a lot of going to the back step, say, um, and you only take 3 credits. Okay, but fine, right? So let's imagine that you have a semester where you are only taking 1 credit. What would you guys say about the ease or difficulty of such a semester? Huh? Yeah, it'd be pretty easy. Okay. Now, let's assume, just for the sake of the moment, that all classes are equally difficult. Okay, and require equally much time and effort to do well in them. Okay. That's not a reasonable assumption, of course, because um, what you know, for every blah 101, you've got con law being taught by Dr. Himsel. Okay, right. So not all classes are created equal. Okay, fine. So, but let's just assume temporarily that all classes are equally difficult. So, if you took 1 credit in a semester, it'd be pretty easy. Yeah? Okay. What about if you took 2? Okay. You could say it's twice as hard. Does that I mean, it certainly would require twice as much effort, but would the semester be twice as difficult? Uh, that's kind of a matter of debate, right? All right, what about if you had 3 classes? Well, okay, that's the question, right? So if, I mean, let's kind of take this to extremes, okay, to kind of see the difference or what I'm getting at. If going from 2 to 3, it does increase the difficulty, okay? Does it increase the difficulty by more, less, or the same as going from 3 to 4? Okay, and remember, assume all classes require equally everything the same. Less, so it takes less to go from 2 to 3 than it goes to 3 to 4? Or would you say more? Okay, what about 4 to 5? 5 to 6? 6 to 7? Right? Okay, so maybe here's a better way to put it. Do you think the increase in difficulty is bigger if you go from 6 credits to 7 credits, or say 2 credits to 3 credits? Okay, what would be the argument for 2 to 3? Okay, it's less than required. Okay, you probably have a lot of free time still, Cole. Okay, fair point, right? A bigger percentage of the whole. So you started with 2, you ended with 3. That was a 50% increase. Whereas if you go from 6 to 7, that's, what, a 16% increase or whatever. Um, okay, what would be the counter argument for 6 to 7? I don't know, how many of you guys have taken a 6 credit semester? Huh? Okay, tell us about that semester. Mm, okay. Why is it hell? Okay. So if I uh and sleep and have a little bit of free time to not go crazy. Yeah. Okay. If you had 5 credits, do you think you'd be able to manage it given the load? If you had 7, what would happen? Right. Okay. If you had 10, what would it be like? Right. Okay. So yeah. All right. So the point there is that, and we could argue about the particulars, right? That the increase of difficulty by adding one class isn't necessarily the same increase. It might depend on how many classes you already have, right? So if you're going from 10 classes to 11, excuse me, um, right, it's already super hard. And so the increase of difficulty might just be like you drop out, right? But going from 1 to 2, nah, that's pretty straightforward difficulty increase. Going from 5 to 6, right? Okay. So point being, um, that each increase in the number of courses doesn't necessarily directly have a linear increase in difficulty. Okay. Okay. So that's sort of a cheesy example, but what we're going to sort of talk about here are um, algorithms, okay, for doing things and trying to measure the complexity of them, which, how long does it take to do them? How difficult are they? How efficient are they? That kind of thing, okay? All right, so where do the poker cards fit into this? Well, go through your poker cards and get out all of the say, the hearts, okay? Just pick a suit, it really doesn't matter. Um, but get out all of one suit worth of cards and then just set the others aside for now. And if you sat around and shuffled them then you should be regretting your decisions right now. Okay. All right. So everybody's got out one suit. Okay. Now shuffle them, but shuffle them and then place them face down so uh, you can't see the top card. Okay. And you don't have to, like, just shuffle them reasonably. You don't have to be like super awesome at this. Okay. Okay. We're not. This isn't Vegas, huh? And next class we'll talk about card count. No, I'm kidding. I don't have enough short-term memory to do card counting. Um, yeah, a tutorial, card counting 101. immersion trip to Vegas. Right? Well, yeah, it is a bunch of MIT kids, right? I mean, let's face it, we're not MIT, but now I don't know. I've never been to Vegas to gamble. I've only actually flown through McCarran. Do you have to be 21 to go into the casinos or 18? Okay. Because if it's 18, that would be money, right? But if it's 21, then that wouldn't work, obviously, for a freshman tutorial. It'd make for a good senior tutorial, like, you know, imagine Dr. Thompson, teaching a probability of poker cards. Which actually, I should mention, is anybody looking for a second half credit semester course? Maybe? Or just you need to add something because you had only a first credit or you've dropped something and yeah, huh? Okay. So there is I think what number did we assign to it? Math 178, I think, or 177. That Dr. Gates is going to start teaching on Wednesday. So it's a second half credit on math of games and sports and things like that. Um, so if you're interested, if that sounds kind of interesting, then come bug me and I'll look up the exact number and then you talk with your advisor. Okay. Anyway, so right. All right. So you've got your poker cards. Okay. Also, pull out your phone or whatever other gadgets you've got, and open up the timer or clock or whatever it's called, right? So that you can do a stopwatch, right? Because I want you guys to do something, and I want you to time yourself in the process. Okay. And if you happen to have a computer, um, go ahead and open that up, or you can use your phone for one other thing that we're going to do. So we're going to do some data collection too. So I've started a Google spreadsheet here, and while you guys are doing the task I'm about to give you, I'll put the link to this on Canvas so that you guys can all edit it, and that way I don't have to type for 20 something people. Okay, so you've got your cards, you've got your stopwatch. Okay, what I want you to do is start the timer and then flip over the cards, and I want you to sort them. Now, we have to decide what order we should put things in. Well, what's the standard order for cards? Okay, ace through king. Do we want to go with that as our ordering? Doesn't really. Basically, all we have to decide is where are we putting the ace. Okay, so let's take the ace as it's a one card. Okay, so you'll do ace, two, three, four, five, six, all the way up through 10, and then you've got your jack, queen, and king in that order. Okay, so start the timer, flip them over, and sort them ace through king. And do that 3 times. Okay, so time it, write down the time, shuffle them, do it again. Okay. And while you guys are doing that, I'll get the spreadsheet linked to Canvas so you guys can edit. Okay, and then just write down your times so that we've got them, and you'll put them in the spreadsheet here in a minute. Oh, okay, so um, after you guys finish doing it 3 times, um, then I'll wait until everybody's done. Okay, so has everybody finished 3 times, 3 trials? Yeah. Okay. All right. So if you've got your computer handy, great. You can do this from your phone too, probably. So I just sent as an announcement in Canvas the link to the spreadsheet. So it might be in your email, or if you're just in Canvas, just go to the announcements tab and you'll see it at the top here. And then there's the link to the spreadsheet. Okay. So, all right, good. So it's live. All right. So go in and it doesn't matter where you put it, right? Just pick a row and uh, put in the number of seconds how much time it took you for each of your 3 attempts here. And um, we're going to do other sort of experiments like this. Uh, and the convention that I'm going to use just for simplicity is if for some of the more complicated tasks, if it takes you more than a minute, we're going to enter just the number of seconds, right? So not 1 minute, 30 seconds, I'd rather enter 90 seconds. Okay, so just the number of seconds, whatever it is. Okay, so start putting stuff in. We'll look at the averages for these things and kind of see how long it took you guys. And kind of, yeah. But we'll just crowdsource the data here. Might as well. Okay, make sure everything's looking good on the stream. Yep. Okay, people are putting in their data. Okay. If anybody doesn't have a computer or can't get to this, you got a problem or no? Oh, in announcements. Yeah, and then it's at the very top. There you go. Just click on that and then click on that. There you go. Okay. Does anybody not have a computer or a way to enter data and I can do it for you? No, we're good? Okay. Um, and look at all the menagerie of animals we've got. We've got an anonymous axolotl. Dr. Rogers would be happy with that. An anonymous camel, an anonymous blobfish. Ooh, a dolphin, an anteater. Uh, huh? How do you do what now? Oh, that's you guys because I just gave you the link because you're not signed into Google, right? Um, yeah, tigers, ligers. Do we have any bears? Oh my, gophers. Anteaters, jackalopes, grizzlies. There's a bear. Yeah. Okay. Um, all right. So nobody's going to use row 16, huh? Oh, 16's an unlucky number? Oh, I guess. All right, it's okay. I'll just delete that row then. Oh, no, there we go. Thank you, Evan, who is the anonymous gopher or anteater. Anteater. All right, so Alex, get your data in. I'm going to delete row 20 here. All right, so I'm going to just average. Oops. Okay, so yeah, I don't need all these digits, but whatever. Right. So what's kind of the let's actually look at the min and the max too while we're at it. Um, okay. Just to get a sense of the variance here. Okay. So does it seem reasonable that about 20 seconds ish is how long it took to do this? Okay. And it took some of you more, it took some of you less. And what what could explain the variance in the numbers, right? Because like let's take the first trial. We had anywhere from 10 seconds to 37 seconds. So what could explain the differences in that? Yeah, Cole. Okay. Strategy. How did you guys sort? We'll talk about that in a minute. Yes. Okay. How well it was shuffled. If you did a really crappy job of shuffling, it might have been the case that half of it was already kind of mostly sorted and you didn't have to do a whole lot to change it up. Okay. Any other thoughts? Yes. How awake you are right now. Good. uh, or not, as the case may be. And if you're, a caffeinated monkey like I am right now, then you're probably going to be super fast. Yes. Okay. Blind luck. I mean, there is a randomness here, right, in the sorting. Um, the other thing is that, I mean, you guys are human. Maybe the first time you hadn't kind of quite gotten your land legs yet, so to speak, right? And your second attempt, even if you had the exact same distribution of the cards, maybe the second time went faster because you were kind of used to what the task was. Okay. Now, if I imagine that you guys were all robots, then some of those variances wouldn't be there, right? The robots are equally awake and whatnot. Okay, but two things. One is how did you sort them? Okay, so this comes down to what algorithm did you use to sort the cards? You used some sort of algorithm. You had to. You may not have been conscious of what it was, but you did. Okay, so how did you guys sort these things? Huh? Okay, so you went through and searched sort of in order. You said, okay, I've got 12 cards, find the ace, put it at the bottom, then find the two, then and so on. Okay? Cole, how'd you do it? Okay, fine. But then once you got the king and you put it down, then what? Okay, so you went and said, "Where's the queen?" Bam. "Where's the jack?" Bam, and so on. Okay, what'd you do? Okay, so you just took them as they came and sort of imagined you had like a row of 12 spaces, or 13, sorry, 13 spaces, and you know that the ace is going to be at the far left and the king at the far right, and so then you just kind of estimated where it would go. Okay, now, do you guys think so? That algorithm, do you guys think that that's more or less efficient than, say, what Cole did, where he searched through to find the king or the king first? Okay, well, what times did you guys get? So, what times did you have? 18? Okay, what about the third? Okay, what was the first one? Okay, so maybe an average of 20, say, for your second and third. What'd you have?
24, 18, 17.
Okay, so all right, maybe in this case, for only one suit of cards, we don't necessarily notice the difference in efficiency. Okay, but I claim that your algorithm would be more efficient if we had 1,000 cards. Okay, now you'd have to imagine a thing with 1,000 spaces, but okay. So what's the potential inefficiency with, say, Cole's version, where he looked through all the cards to find the king? It could be the last card, right? So what's the worst case scenario for Cole is okay, but all right, so let's yeah, okay, that fair point. And this is one reason you wouldn't necessarily notice the inefficiency there. Let's say that you could only look at one card at a time, right? So even if they're all spread out, like I put blinders on you so that you can only see one card at a time. Okay. If that's the case, or let's say you put all of them face down and then you've got your sorted stack over to the right. Okay. Then what could be inefficient? You flip over a card and you say, is that the king? Yes or no? If it is, great. You put it in the pile and move on to the queen. If it isn't, you put it back down and then you move on to the next card. Okay. So what would be the worst case scenario there? Ironically, it'd be if they were already sorted in order, right? Because by it could be that when you shuffle them and they just so happen to be in exactly the correct order. You know, the odds of that are pretty low, but it could happen, right? Yeah, it'd be what? 2 to the 1 and 2 to the 13th, which is what? Well, what's 1 divided by that?
Oh.
So 2 to the minus 13th. Okay, so that's a 0.01% basically, uh, which is to say, not happening. Okay. Um, yeah. So, right. Okay. So that particular algorithm may or may not be the most efficient way to do it, but it's the algorithm that Cole picked, and so let's stick with it. Okay. For him anyway. All right. So, what do you guys think is next here? Let's add a suit. Okay. Now, add a suit. Uh, we've got a choice here, right? Because what happens if you add a suit that's the opposite color of what you've already got? It's very easy to see. Uh, so let's do that case first. Okay, so whatever suit you picked, pick a suit of the opposite color. Okay, and then what I want you guys to do to sort them is so you all have one red suit and one black suit, and let's just arbitrarily decide that all the red cards go before all the black cards. Okay, so you'll have ace through king red and ace through king black after that. Okay, All right, so do the same thing. Time yourself after you shuffle them. Okay, well, first dig out the appropriate suits. Um, sure, yes. So you will have one stack of shuffled cards, not two stacks of shuffled cards. Okay, because, and why? If you had two stacks of shuffled cards, how much time would you expect that it would take to do this? Precisely double the amount of time it took to do one suit. Okay, because you could just split it, do the red ones, then do the black ones, and then stack the two results on top. Okay, if they're all shuffled together, can you necessarily take that approach? Not necessarily. Okay. Okay, so again, same thing. We're going to do 3 trials of this. Um, hopefully, everybody that's in the chat, Coy, Mr. Hargraves, uh, Alex. Hopefully, we're doing good this morning.
Blackjack dealer college.
Yeah. Why not, right? Did you drop something? Okay. Kent said he feels like he's in blackjack dealer college now. You guys mind if I get a picture, couple pictures of you guys doing this? Yeah? Can I get a thumbs up? There we go. Call.
Oh, this is messing up my calculations.
Oh, sorry. When you're finished.
I'll be photogenic later.
Okay.
Okay, I'm ready.
Okay, now you're photogenic.
I'll pretend like I'm doing
Okay. All right, ready? Okay. Good. Let's see your nicely sorted stack there. We'll pretend you're finished. All right, give me a nice smile. Well, or, yeah, there we go. All right. Got the Math and CS Department Facebook page, and, you know, got to make sure all the followers on Instagram are
happy.
following all the fun haps in the department.
Keep doing it.
All right, good, Alex. Coy, glad to see you're doing well. And Alex, pourquoi vous n'êtes pas présent dans les cours? Oui? Huh? Coy is in Vietnam, so it's a bit of a long commute for him. Uh, yeah. So now, as for Monsieur Alex, uh, Alex habite à Kappa Sigma, n'est-ce pas? Oui. Oui. Alex Nagaba. Oh, oui, 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 T. Oh, j'oubliais. Or j'oublie. Je suis désolé. Um, all right, so data's flowing in. Looking good. Oh, you did it that way. Okay. No, but right, you did that as opposed to right. So it it doesn't really matter for the sake of demonstration. But you did the two aces, then the two twos. Yeah. You could have done it so you had all the red cards and then all the black cards. Oh. Right. I think that's what I intended, but that's okay. Oh, okay. You've already done it, so fair enough. Yeah, yeah. I mean, they would be pretty similar, right? Um, with possibly one distinction. If you're doing all the red and all the black, it opens up one other algorithm, which we'll talk about when everybody's finished. Um,
I can do it again.
That's all right, unless you just want to. Yeah, so just write the number of seconds. So it'd be what, 73? Yeah. That way we don't have to do annoying conversions. Okay, so it looks like most of you have finished all three attempts. RT, what's your problem, man? Uh, you just haven't entered them yet. Okay, that's all right. All right, well, let's just, while these last few pieces of data are coming in, let's go down and just sort of look at the averages, um, see what we're dealing with here. Um, so, on average, what does it seem like we're kind of settling down on? The upper end of the 40-second range, right? So, we've got a range from, say, 52 seconds average on the first attempts to 45 on the third. And maybe it's not too surprising that you guys got a little faster as you went, right? And we actually noticed sort of the same thing on average with our first set of data. Okay, so what should we say, maybe roughly speaking, is the amount of time it took to do this with two suits? 45, 50, right? Let's just call it at 50 seconds just for sake of demonstration. Well, what did we say it was for one suit? 20. Okay, so how many of you guys would have been expecting the two suit to be 40 seconds instead of 50? Okay, so 40 seconds would be exactly double the work. But this was actually more than twice the amount of work, even though it was just twice the amount of cards. Why do you think that is? Yeah.
You also have to look for every double the cards too.
Well, okay. So in the algorithm that you chose, you had to do that, right? So okay. So yeah. So what was Cole? What was your algorithm? You had all of the cards, and you searched through them until.
I went king black, king red, queen black, queen red.
Okay, so that's the order he did it in, rather than all the reds and all the blacks. Okay, well, here's one easy example. So, how many of you guys sorted it all the reds and then all the blacks? Okay, that's what I had intended, but that's okay. Um, Rip. So, let's say you're sorting it to do all the reds first and then all the blacks second. Okay. Uh, what would be one way to have approached this problem when you've got two different colors? You could separate the two, right? You've got a big stack, they're all mixed up. You could say, all right, the first thing I'm going to do is I'm going to separate all the reds into one stack and all the blacks into the other. And then I will individually sort each of the stacks black and red. Okay? Make sense? Perfectly fine algorithm. Does it make sense that that would take more than twice the amount of time? Yeah, because the first thing you've got to do is sort them into the two respective piles. And then you still have to do double the amount of work from before. Okay, so there was an extra step thrown on top. Okay, now we're running out of a little bit of time today, so I'll give you guys sort of a an assignment to do later. But um, the what would you expect to start happening if I had you do this for 3 suits and then 4 suits? Okay, yeah, what would you expect, Ken? Okay, it's going to increase. And the question is it exponential? Is it like polynomial? Uh, what's the increase in difficulty or complexity as we increase the number of suits or equivalently the number of cards? Okay, so that's kind of the question that we have is what is sort of the increase in things here um, for the number of cards or suits? Okay. And then we're doing this sort of on an average basis because I just had, all of you guys do this. But then the other question would be, well, we've noticed that you guys had different procedures for doing this sorting, right? And our gut feeling is perhaps that one of them might be more efficient than another. All right, now it also kind of depends on the meat bag that's executing it, okay, which is to say the computer that would be executing it, right? In the if we were to program this sort of thing. So for each of these sort of different algorithms, it might be the case that one algorithm increases difficulty exponentially, but another only increases in a polynomial way or a linear way. Okay, depends on the algorithm, depends on the complexity, what the procedure is, right? So that's kind of the big picture as to what we're going to be discussing on Friday is starting to dive into the details of how much extra work did it take and how can we maybe with a little bit of math talk about this more precisely. Now, how many of you guys are either in calculus or took some calculus? Okay, so one of the things that we're kind of interested in is what we call asymptotic analysis, meaning that what would happen if I let the number of cards go to sort of infinity here? Okay, I want to sort of know what's that long-term behavior. Now, obviously, if you had infinitely many cards, this would take an infinite amount of time. The question is, how does it get to infinity? Does it get to infinity in a straight line? Or does it get into infinity in like a parabola shape? Or is it something like a 2 to the x shape, which is even faster? Okay, so depends on the algorithm that we're looking at. And sort of the staple algorithms to consider in computer science would be things like looking things up in a table. That's something you have to do on a computer a lot. Searching through a bunch of things to find a given item, sorting a bunch of things, uh, algorithms like that. Okay, so that's why I took the cards sorting as our example here. Okay, so we'll quit here in a minute, but let me give you guys your assignment for um, um, the the rest of it. So I'm going to add in some more columns here. Okay, so for doing this with say 3 suits and doing it with 4 suits. Okay, so the entire thing. And again, let's just we have to choose an order here for how these things should be. So most of you did the following order. So let's stick with that. When we had 2 of them, you just put the red ones on the bottom and the black ones on top. Okay. Now, for 3 and 4 suits, obviously, we've got to choose a more specific order. What's the standard order in poker for what trumps what? Okay. What's the lowest suit? Clubs. What's the next suit? Hearts, then diamonds, or is it the other way? I think it's hearts first. Okay. Yeah. Huh? Yeah, which suit's better, right? So if I put down like 2 ace of spades and you put 2 ace of hearts, I win, right? Um, okay, so Ethan, look up the order, would you please, real quick? Got it?
It's diamonds, clubs, hearts, spades.
Oh, okay, my bad. All right, so diamonds on the bottom, clubs next, hearts next, spades next for doing it for 4. And if you're doing it with 3, just go in that order for whichever 3 you pick. It doesn't matter, obviously. Okay. All right. So your assignment, and if you guys could do me a favor and finish this by the basically like 5 o'clock tomorrow afternoon, so that I can do some data analysis on it tomorrow night before class on Friday. Okay, so yeah, go into the sheet, and you dirtbags who weren't in class today, or you dirtbags who didn't come by my office to get a stack of cards, or you dirtbags that are in foreign countries, uh, if you don't have a deck of cards, grab a deck of cards so that you can do this. Those of you who are on campus, like Alex, you somehow managed to find a deck of cards supposedly. But if you need a deck of cards, there's a little wood box on the wall outside my office door, Goodrich 109. I'm just going to put the leftover cards in there. So if you need to grab one, just grab one. And so take your cards, and all of the plastic wrappings are going to go where? In that nice little trash can over there. Okay. All right. So yeah, please finish this by the end of tomorrow afternoon so that I can do the data analysis tomorrow night in advance of Friday. All right. See you guys later.